Well, today we are going to discuss about conic section. What is conic section? How it is formed? What are the types of conic surfaces? How they will be formed? What will be the equations for each? And what are the characteristics of conics? Based on the characteristics, we will discuss various problems on the conic section. So, let us take how a right circular cone is formed. How the cone will be formed. I will explain it. Take a fixed line. Take a fixed line. And there is another line which is rotating about the fixed line. When this rotating line is rotated such that the angle between the fixed line and this rotating line should be constant. It is always be constant. Then it will be formed like this. At the one extreme end, it will be here. In the other extreme end, it will be here. A right circular cone is formed. So this is a right circular cone. Right? In this right circular cone, this line will be called as axis of right circular, and this line is called as generator. This is called as generator, and this is called as axis, and the point at which the axis and the generator meet will be called as vertex. The angle between the generator and the axis will be called as vertex angle. The two cones is separated at the vertex. This upper portion is called as upper nape. This is called as lower nape. This is what it is known as the right circular cone. Okay. If this right circular cone is cut by a plane, then we will have a conic surfaces. We will get the conics in general. It may be cutting perpendicular to the axis. The plane may be cutting perpendicular to the axis. It may be inclined at an angle with the axis, or it may be parallel to the axis. Depending upon the position of intersecting plane to this right circular cone, we will be formed a conic. I got it. So this is what? This is called as axis. This is called as generator. If this axis, around the axis, if the generator rotates such that the angle between the generator and the fixed axis, fixed line, if it is constant, then a cone will be formed. Here, this angle is called as vertex angle. This is called generator. Whatever the upper portion is there, it is known as upper nape. This is called as lower nape. The circumference, this of a circle, and the axis is always perpendicular to the base of the circular base, Okay, this circumference is called as directrix. This is known as directrix. So by cutting this right circular cone by a plane at different angles, at different positions, we will form a conics. That is, you may form ellipse, ellipse, you may form parabola, parabola, or hyperbola. There is a special section of conic, sorry, ellipse will be called as circle, right? So all these things are seen in a video. Small animation is there. You can see that animation. Madam, animation. That animation, you can observe it. How a circle is formed, how a ellipse is formed, how a formed, how a hyperbola will be formed. Because here I cannot show how the plane cuts, right? You just see this video, you can observe the clear formation of conic sections. So this is a line, fixed line. So there is a cross line will be called as generator. Both will meet at a point. The yellow dot will be called as vertex. And if it is rotated, you will form a double right circular cone. I got it. The blue part, it is upper cone. That junction is known as vertex. That is called as vertex. The line, vertical line is axis, and the crossed one, it is called generator. Circular base, the cone is having circular base, and the base is always perpendicular with the axis. The axis is always perpendicular to the base, right? That is called as directrix. The circumference of the base is the directrix, and this surface of the cone will be called as nape. We have two napes. One is upper nape. The blue part will be the upper nape, and the lower one, which is having yellow in color, will be called as lower nape, right? Say this right circular cone, and the angle, vertex angle is what? It is angle between the generator and the axis. If this, see the plane, how the plane is crossing the right circular cone. It may in different positions. The green portion will be taken as a plane. So it may cut. See, if it is perpendicular, how it is looking? It is like a circle, right? Now this is the ellipse. Here the angle between the plane and the axis is always greater than the vertex angle. See, if it is this the case, here we will be formed a, see how the ellipse is formed. Plane which is cutting or intersecting the cone. See, the angle B is less than angle A. Angle B is angle between the plane and the axis. This is called as ellipse. The special case of ellipse is circle. How circle forms? When the angles are same. Angle between the axis and plane with the vertex angle. See how the parabola is formed. Angle between the axis and the plane. Vertex angle. Vertex angle. Then parabola is formed. So this, observe the parabola. And now hyperbola is formed. Observe this. Here the axis is always parallel to the plane. Parallel to the plane. There hyperbola will be formed. See this. See this. Hyperbola. So these are the three different conic sections we should learn. One is ellipse, other one is parabola, and other one is hyperbola. Right? Let's stop. So ellipse, it will be looking like this. This is ellipse. X-axis will be the major axis, Y-axis will be the minor axis. In some case, it may also form like this. Here, Y-axis will be taken as major axis, X-axis will be taken as minor axis. Parabola. So this is parabola. Here, the axis is X-axis. Axis of the conic or axis of the parabola is what? X-axis. There will be four forms of parabola. See, this is one case. This is other case. This is third case. And this is fourth case. These are the types of parabolas. Hyperbola is like this. Hyperbola is this one. Okay. This is the ellipse. This is what? Parabola. And this is hyperbola. As we know that the circle. So these are the different conics we can obtain. How? By intersection of a plane at different angles and at different positions to a right circular cone. Is it right? Next, let us define some of the important terms related to the conic section. So what is conic? Let us define a conic. Conic is defined as a locus of a point. Locus of a point. What is locus? It is a moving point. Locus is what? It is a moving point which moves under certain geometrical condition that will be called as locus of a point. I will give you the familiar example. Take a point. This is point P, which is moving point. If this moving point moves such that its distance from a fixed point, this is what? It is a fixed point. It is what? Moving point. locus. Moving point is always called as locus. This moving point moves such that its distance from a fixed point is always constant. Then how it rotates, how it move. When this distance is always constant means it should move like that only. Isn't it? It move like that only. So what is the path traced by the moving point? What is the path traced by the moving point? The path traced by the moving point is the circle. In the same way, ellipse, parabola or hyperbola, all these things are formed by or traced by a moving point under a given geometrical condition. Got it? Locus of a point is nothing but a moving point which moves under geometrical condition. Whatever the path traced by the moving point under that condition will be the conic. I have shown for a circle. Let us take in general moving point. Moving point is the locus. So conic is defined as locus of a point which moves such that so I will take this is P, moving point, which moves such that its distance from a fixed point in the plane and the distance from a fixed line, perpendicular distance from a fixed line, the ratio must be same. The ratio must be same. This is what? This is fixed line. This is what? Fixed point. This is what? Moving point. Here, from a fixed point, this length is always constant. Therefore, in a circle, radius is always constant, right? Like that, in general, I will say that the ratio between the locus of a point, conic, it is defined as the locus of a point which moves such that its distance from a fixed point S and its distance from a fixed line L, their ratio is always constant. It means SP divided by MP is always constant. Okay. If this constant is 0, circle is formed. If this constant is 1, if this constant is 1, parabola will be formed. Greater than 1, ellipse, less than 1 is hyperbola. Okay, you got it. Conic is the locus of a point which moves such that the ratio between the distance, its distance from a fixed point to its distance from a fixed line, perpendicular distance to a fixed line is always constant. The ratio of SP by MP is equal to constant will be called as E. This is known as eccentricity. It is known as eccentricity. This is the definition of a conic. Okay, so the conic may be circle, the conic may be ellipse, the conic may be parabola, the conic may be hyperbola. It depends only on what? Only on this ratio. You may get 0 for circle, you may get 1 for parabola, you may get 1 greater than 1 for ellipse and less than 1 for hyperbola. Okay, let us take the definitions of conic. As I mentioned here, the fixed point will be called as focus. The fixed point is called as focus. The fixed line is called as directrix. The fixed point is called as focus, and the fixed line is called as directrix, and the line which is passing through the focus, the line which is passing through the focus and perpendicular to the directrix, which is called as axis, which is called as axis of conic, which is called as axis of conic. Got it? There are other definitions which are very important in understanding the conic. Is we got the definition of focus. What is focus? It is the fixed point in the conic. What is directrix? It is fixed line. What is axis? Axis will be a line which is passing through focus and perpendicular to the directrix. Next, vertex. Vertex is a point. It is a junction at which the conic and the axis meets. The conic and the axis meets. So if I take, see, this is the axis, and this is the conic surface. They are meeting at this point, will be called as vertex. In case of ellipse, if it is major axis, x-axis is major axis. See, this is the surface of conic meeting the axis. This is vertex. This is also point at which the surface of conic and the x-axis or axis of conic meets. This is also vertex, right? So, in case of hyperbola, this is vertex. This is vertex, right? Vertex is a point at which the conic and the axis of the conic meets, right? Next important definition, chord. Chord is the straight line which is joining of the 2 points on the surface. 2 points on the surface. So, if I take, this is 1 point on the surface, 1 point on the another surface. This will be called as chord. This is chord of a conic. Here, this is chord of a conic. This is chord of a conic. What is chord? Chord is a straight line which is joining of the 2 points on the surface of the conics, right? Focal chord. Focal chord. We got the definition of chord. Chord is a line which is joining of 2 points on the surfaces of the conic. Okay. What is focal chord? Focal chord is also a chord which passes through the focus. Which passes through the focus. Suppose this is focus. This is focus. Yes. If the chord passes through that, will be called as focus chord. So, focus chord is what? It is a chord which passes through the focus. Okay. Double ordinate. Double ordinate. So, double ordinate is the chord if it is perpendicular to the axis. See, here both the chords I have written are perpendicular to the axis. Such points are called as double ordinates. They are known as double ordinates. Very important, latus rectum. Latus rectum. So, the double ordinates passing through the focus is called as latus rectum. See, this is a double ordinates because the chord is perpendicular to what? Axis, and which is passing through what? Focus. Hence, This between, this is called as latus rectum, LR. Latus rectum. Center. Center is nothing but the point which bisects every chord of the conic passing through it. It is known as the center of the conic. The point which bisects every chord of the conic passing through it will be said to be a center of the conics. These are the general terms which are related to a conic. Got it? So what are the important definitions we require to understand the conic? Vertex. What is vertex? Vertex is a point at which the axis and the conic meets, right? This is vertex of parabola. Next, what is chord? Chord is a line between the 2 points on the surface of a chord, right? On the surface of conic. Focal chord, any chord which is passing through the focal. What is double ordinate? Double ordinates are the 2 points on the surface of the conic. It is perpendicular to the axis, right? What is focus? Focus is the fixed point. What is directrix? It is a fixed line which is always perpendicular to the axis, right? So what is axis? Axis is a line which is passing through focus and the perpendicular to directrix. Very important. Eccentricity. So eccentricity is what? It is the ratio. It is the ratio of distance of locus of a point, its distance to the fixed point, to its distance to the fixed line. This is called as eccentricity, right? Based on the eccentricity, we can say if the eccentricity is equal to 1, it is the parabola. If these two ratios are same, it is parabola. If it is less than 1, or it is less than 1, it is what? Ellipse. Greater than 1, it is hyperbola. Equal to 0, it is circle. Special case of a conic. Earlier I was mentioned that if E is less than 1, it is hyperbola. Just make it correct. If E is less than 1, it is ellipse. If E is greater than 1, it is parabola. Okay. Next, we will discuss the types of conics one by one. The first one is parabola. What is parabola? Parabola is a type of conic, right? How it is formed? How it is formed? Every conic is a locus of a point, correct? Every conic is a locus of a point. Parabola is also a locus of a point such that the ratio between its distance from a fixed point to its distance from a fixed line is always constant. P is moving point. How it moves? It moves such that the ratio between this distance to this distance is always equal to 1. That means eccentricity is equal to 1. That type of curve is called as parabola, right? So this fixed point is focus, fixed line is called directrix, and the ratio is eccentricity. Eccentricity is what? It is always E is equal to 1. What are the, how a geometrical representation of parabola? Under these conditions, if the point, moving point moves under this condition, what is that condition? The ratio between SP to MP is always equal to 1. What? The geometrical curve is obtained. Geometrical representation of a parabola as its vertex at origin and focus as a comma 0. A comma 0. Say this diagram. This is x-axis. This is y-axis. This is the parabola. Yes. So coordinates of S is what? Suppose its distance from this point to this point is A. Coordinates of S is what? A comma 0. That is S. This is the axis. This is taken as what? Vertex. Which origin? No? X-axis and y-axis meet at this point. Therefore, whose coordinates are 0 comma 0. And this is directrix. This is the directrix. Latus rectum. L, S, L dash will be called as what? Latus rectum. So this distance is 2 times of A. This is also 2 times of A. Therefore, coordinates of L will be A comma 2A. This is A comma minus 2A. This is the geometrical representation of a parabola. Right? The equation is given by y square is equal to 4ax. Equation of parabola is y square is equal to 4ax. This is for axis will be the x-axis. Axis will be the x-axis. Axis of parabola is always at x-axis, and vertex is what? Vertex is origin a comma a of 0 comma 0. Right? Let us take the characteristics of parabola. Let us take the characteristics of parabola. Characteristics of parabola. Number 1, vertex. As I mentioned, vertex A, whose coordinates are what? A of 0 comma 0. Second one, focus. Focus. What is focus? Focus is A comma 0. Focus is A comma 0. Third important point, axis of parabola. Which is axis? This is axis of parabola. What is this? It is x-axis. X-axis. On x-axis, y is always 0, right? Ends of latus rectum. Ends of latus rectum. Which are the ends of latus rectum? What is latus rectum? It is a chord which pass through focus and perpendicular to the axis, right? That will be called as latus rectum. The coordinates of ends of latus rectum are L is having a comma 2a, L dash is equal to a comma minus 2a. If I want length of latus rectum, which will be obtained by distance formula. As we know the coordinates of L and L dash, with that we can calculate the length of the latus rectum. The length of latus rectum obtained by using distance formula is always be equal to 4a. Length is 4a. Equation of latus rectum, that is x is equal to a. Equation of latus rectum, it is x is equal to a. Equation of directrix, that is equal to x is equal to minus a, or x plus a is equal to 0. X plus a is equal to 0. Then last one, eccentricity of parabola is equal to 1. These are the characteristics of a parabola, right? So I'll repeat it here. Parabola is the locus of a point which moves such that the ratio of its distance from a fixed point to its distance, perpendicular distance to the fixed line, that is directrix, is always equal to 1. That curve will be called as parabola. How it is geometrically obtained? We can obtain like this. We have 4 types of parabolas. So this is positive x-axis. Suppose if it comes this side, this will be like this. So equation will become y square is equal to minus 4ax minus 4ax. Y square is equal to minus 4ax for what? If the parabola is like this. X square is equal to 4ay. This is for this type of parabola. X square is equal to minus 4ay. This is for what? This type of parabola. So these 3 are out of syllabus. We have a parabola as x-axis is its axis of parabola, that we have to discuss here. So this is the geometrical representation of parabola. Derivation of equation of parabola is not required. Just have the equation of parabola and have the characteristics of parabola. Based on this, we have to work out a simple problems. The problems of what type? We have to take the equation. We need to substitute directly the given values to form the equation of parabola. Otherwise, there will be given some equation. With that equation, we need to find out these characteristics directly. Very simple problems we have to work out, right? You need to remember the equation of parabola as well as characteristics of parabola. That's all. You take the problems. Find the focus, eccentricity, vertex, and length of lattice and rectum of the following equations. The first question is y square is equal to 8x. Y square is equal to 8x. The equation of parabola of standard form is what? This is always compared with y square is equal to 4ax. The given equation and the standard equations are compared. So y square at the left side. Right side we have 8x for the given parabola, and for the standard one it is 4ax. What is the difference? In place of 4a we have 8. Correct? Value of a. So from above 4a is equal to 8. Therefore, a is equal to what? 8 divided by 4 is equal to 2. The value of a is equal to 2. Now we can write the other values, required values. First point. What is first point? We need to write focus. You see the characteristic. The focus is what? S is equal to what? A comma 0. S is equal to a comma 0. Therefore, what is answer? Answer is A is what? A is equal to 2. 2 comma 0 is the focus. Right? Second one. What is second one? Eccentricity. Need not to be calculated. It is fixed. Right? It is always constant. Eccentricity of parabola is always 1. You write directly. Then we have to write what? Vertex. C is what? Vertex. For a parabola, as x-axis is taken as axis of parabola, in that case, what is vertex? Origin is the vertex. A is equal to 0, 0. Right? Next is what? Length of lattice rectum. Length of lattice rectum. As we know that length of the lattice rectum is 4a, isn't it? Just write the value of a. 4 into a. What is a? A is 2. That is equal to 8 units. It is 8 units. Got it? This is the way in which we can get the characteristics of the given parabola. Right? Next, let us take the other problem. Second one, y square is equal to 16x. Y square is equal to 16x. This compared with the standard one. What is standard one? Y square is equal to 4a. Therefore, by comparing these two, comparing the standard equation of parabola and the given problem, we have, by looking the problem, we can say that It is of this form. Suppose if there is a negative sign, it indicates what? The parabola of this type. Parabola of this type. Right? So for a x, in place of 4a, we have 16. Therefore, a is equal to what? 16 by 4 is 4. We got a is what? 4. We require focus. Focus is equal to s is equal to what? A comma 0. Correct? A comma 0. The answer is a is 4 comma 0. Next, second one, it is fixed value. E is equal to 1. C. Third one, vertex. So vertex of parabola, it is 0 comma 0. Next, length of lattice rectum is equal to 4a, that is 4 into a, that is 16 units. 16 units, right? Take the next problem. The next problem is 5y square is equal to 9x. 5y square is equal to 5x. We have a standard form, y square is equal to 4ax. Here it is having coefficient. You have to remove that coefficient, right? So that we have to divide with 5 on both sides. Okay, on both sides. It becomes what? Y square is equal to 9 by 5x. Y square is equal to 9 by 5x. Right? Now write the following characters. Focus. Just compare this with standard one to get a value. Instead of 4a, we have 4a is equal to what? 9 by 5. Therefore, a is equal to what? 9 by 5. This 4 goes to denominator, right? 9 divided by 20. Is it right? The A is equal to 9 divided by 20. Focus. S is equal to a comma 0, that is equal to 9 by 20 comma 0. Eccentricity 1. Vertex is a of 0 comma 0. Length of lattice rectum is 4a. 4 into a. What is a? 9 divided by 20. 4 1 ja, 4 5 ja. That is equal to 4 by 5 units. For any given equation of parabola, we can get the characteristics of parabola. Let us work out how equation is formed with the given data. Find the equation. Find the equation of a parabola. Find the equation of a parabola, comma, whose vertex is 0 comma 0 and focus 4 comma 0. As we know that what is focus? Focus is equal to 4 comma 0. It is nothing but a comma 0. Therefore, what is a? A is equal to 4. Correct? We got a. Hence, equation of parabola is what? Equation of parabola is y square is equal to 4ax. Substitute it. Y square is equal to 4 into a is 4 into x. Y square is equal to 16x. Like that. If you know the focus vertex, with that we can get the equation of the parabola. See the next type of question. Find the focus and equation of directrix. Focus, comma, equation of directrix and length of latus rectum of y square is equal to 16x. Y square is equal to 16x. To take this with standard one, it is 4ax. Therefore, what is 4a? It is 16. A is equal to 16 by 4 is 6. Right? We got a. So with that, get focus. Focus is a comma 0, that is equal to 4 comma 0. Second one, equation of directrix. What is equation of directrix? X is equal to minus a, correct? Equation of directrix, x is equal to minus a, or x plus a is equal to 0. Therefore, x is equal to minus 4, or x plus 4 is equal to 0. X plus 4 is equal to 0. Third one, length of latus rectum is equal to 4a. 4 into 4, it is 16. If they ask equation of latus rectum, equation of latus rectum is what? X is equal to a. So x is equal to 4. So by knowing or by remembering the characteristics of parabola, you can get these characteristics for a given parabola, right? Sometime they will give you the equation, with that they will ask you the characteristic. Sometime they will give you some characteristic, based on that they will ask you the equation of parabola, right? Work out more number of problems, then it will be easy to remember the characteristics of parabola, right? So with this, I will conclude my today's class. Thank you. If you have any question, please